Right, this is chapter 5, implementing intrusion prevention system, IPS. Okay, they are more commonly used in a business environment, especially where the businesses which are more prone to let's say network attacks. So we're going to be looking at the IPS technologies, intrusion prevention technologies. We're going to look at the IPS signatures and how we can implement IPS on our network. Okay, so in the first session, we're going to be focusing on IPS technologies. So when you talk about the security, the security challenges that today's network administrator face, they cannot successfully manage by a single application. Okay, although implementing device hardening or authentication, authorization, accounting, the AAA concept that we discussed before, and the firewall features are all part of properly secured network, but these features still cannot defend the network against a fast-moving internet worms and viruses. Okay, in this scenario, a network must be able to instantly recognize and mitigate worms and viruses threat. And also it is not possible to contain intrusion at a few points in the networks. And therefore the intrusion prevention is required throughout the entire network to successfully detect and stop an attack on every inbound and outbound points of the networks. So in order to do this one, we got technologies called IDS, which is Intrusion Detection System, and IPS, which is Intrusion Prevention System. Okay. Now, before we do that one, there is something called a zero-day attack. So what's a zero-day attack is? It's a kind of attack that sometimes also refers to as a zero-day threat. Is a computer attack that try to exploit a software vulnerability or loopholes on a particular software or operating system that are currently unknown or undisclosed by the software vendor. Okay, for example, sometimes you heard about zero-day Windows attack. So they are those sort of attack which Microsoft was not aware of before, or they were not disclosed by the Microsoft, and they've been exploited by the hackers. Okay, they are known as a zero-day attack. And now, in order to protect against these zero-day attacks, it's important to have a system like IDS System. So it's one approach to prevent worms and viruses from entering a network. Okay, and what you can do, as you can see in the figure over here, let me use my, okay, no, this one. Let me use a pointer. You can see in the figure over here, we got something called IDS System. Okay, so what the IDS System does, it basically get the copy of the internet traffic from the switch. It analyze it. It got the sensor built in. It analyze that traffic and see if it's if there's any viruses or any worms or some malicious sort of traffic which is entering into the network. Now, the only problem with this sort of technology is basically while he is inspecting, this IDS is inspecting your traffic, the traffic will be allowed to travel through the network. So that means it can affect your network. The advantage is because you're not stopping this traffic. That means the traffic, there is no any adverse effect on the traffic, because the traffic doesn't have to wait for IDS system to check for a virus or any other malicious, let's say, attack, and it's happened on a side. So it caused both advantage and disadvantage. So the advantage is really there is no negative effect on network performance. Disadvantage is you will not be able to stop any malicious single packet attack, okay, to reaching your target computer. So in order to respond to this this drawback of IDS system, Cisco implement something called IPS system, which is intrusion prevention system. Okay, this system implement in an inline mode, so that means all the traffic going to go through the IPS system, and anything that the IPS system will find malicious, it will bin it, or call a bit bucket. It will put it in a bit bucket, and all the genuine stuff will be allowed to go travel on to your network. So another advantage is it can stop a single packet attack, which was the issue with the IDS. It cannot stop a single packet attack because while he's monitoring, the packet is still going through the network. And respond immediately, not allowing any malicious traffic to pass. Advantage, obviously, operating in line mode is that IPS can stop single packet attack. Disadvantage is a poorly configured IPS or non-proportional IPS solution can affect the packet flow of forwarding traffic. Okay, so the both technologies got their advantages and disadvantages. Now, if you want to look at the similarity between IPS and IDS system, the both technologies are deployed as a sensor. Okay, and both technology use signatures to detect. Signatures are kind of rules, that you can get, that Cisco get from their overall. They got an overall system, a database of the latest attacks, and the signatures are really the information or the file of all the latest attacks which happens. Okay, so they both technology uses the signature to detect pattern of misuse in the network traffic. Both can detect atomic pattern like a single packet, and also composite pattern, which is multiple packet attack. So both technologies can detect both atomic and composite patterns. And further advantages and disadvantages, the advantage of IDS systems are somehow disadvantage of IPS system, and advantage of IPS system, they are disadvantage of IDS system. So sometimes they are used together as well. So one advantage is no impact on the network. Okay, so it can have some impact on the network, the IPS system. That's a disadvantage. No network impact if there is a sensor failure. Okay, there will be effect on the network if the sensor cause some issues. Okay, no network impact if there is a sensor overload in terms of IDS, but there will be a significant effect on IPS system. With IPS, advantage are they stop trigger packet, can use stream normalization technique. Over here, the response action cannot stop triggers. Okay, and they also correct tuning required for response action, and they are more vulnerable to the network security evasion techniques. So these are some of the advantages and disadvantages of IDS and IPS system. Now let's look at the network-based IPS implementations, how we implement this one. So there are two types of implementation. One is called host-based IPS, and another one is called network-based IPS. In a host-based IPS, software is installed on a single host on each individual computers, okay, to monitor or analyze any suspicious activities. These host-based systems, it can be thought of as a combination of antiviruses, anti-malware, softwares, and firewalls. Okay, and their advantages are they provide protection specific to a host operating system, provide operating system and application level protection, and protect the host after the message is decrypted. Disadvantages are operating systems dependent, so you cannot use the software which is built for Microsoft on Mac operating system, and they must be installed on all the hosts. This is one of the pain when you are, let's say, managing thousands of endpoints. Then the another types are network-based IPS. They are cost-effective, operating system independent as well, which is the issue with the host space, and they cannot examine encrypted traffic, which is one of the drawback, and they must stop the malicious traffic prior to arriving at the host. This is again one of the disadvantage of their network-based IPS. Now we're gonna look at network-based IPS sensor in more details. In the pictures, you can see they are deployed over the network. One sensor is here on a corporate network. Then in between the router and the firewall, we go another one that protect the management server. Then there we go the sensor that protect the web server and the DNS server. And the network-based IPS can be implemented using a dedicated or non-dedicated IPS devices. The network IPS implementations are very critical component of intrusion prevention, and they are host-based IDS IPS solution, but they must be integrated with the network-based IPS implementation to ensure the security, reverse security architecture. Right, so we have some hardware. These are some of the examples, okay, of the devices which are available from Cisco. And then when it comes to choosing an IPS solution from the list which I just showed it to you, there are a number of factors that you have to consider. First of all, one of the factors is amount of traffic, then network topology which is in place, and how much budget you got, because each comes with a different price tag, and again whether you got the resources to manage the IPS system or not. I have a video link on this one that describe more in details about how to choose the particular device, and the link is here, so I will forward you this presentation as well, so you can you can watch this video after this lesson. Again, more advantages and disadvantage of network-based IPS system. We discussed this one briefly. It's a cost-effective but not visible on the network operating system independent, which was the issue with the host-based IPS system. It's a low-level network event scene. They cannot examine encrypted traffic. This is something that we mentioned before as well. This is one of the disadvantages. And they also cannot determine whether the attack was successful or not. Okay, so they can detect it, but they don't know whether the attack was successful or not. They can alert you that there was an attack. Now, when it comes to the mode of deployment, we got two modes. As you can see in the figure, packet, they do not flow through the sensor in promiscuous mode. Uh, the sensor analyzes a copy of monitor traffic and not the actual forward traffic. So this is your actual one, and this is where your IDS system is. Okay, and it get the copy of the message and they analyze that copy. While in inline mode, you place your IPS system in between your devices, and then it will basically go. It will monitor each and every packet. Okay, so that's the two modes through which you can deploy the IPS system. Now the next one is the Cisco switched port analyzer. Okay, the packet analyzer can be a valuable tool to help monitor and also troubleshoot a network. Uh, they are also known as a packet sniffer or a traffic sniffer. They are typically they are mainly a software that capture a packet entering and exiting the network interface card. Okay, it is not always possible to or desirable to have the packet analyzer on the device that is being monitored. Sometimes it is better to have a separate station designed to capture those packages. Here you can see example of port mirroring, through which we are one of the feature that allow a switch to make a duplicate copy of incoming internet frame and then send it out on a port where you have the packet analyzer attached, or you install that one. Okay, so there are two ways you can install and do this. Either you can use a hub, okay, and then the hub will receive this packet and send it to, as you know, this is how hub operates. They basically broadcast everything they receive, they're going to broadcast. So you can either use this one. We don't really use hub anymore, but but you can use it if you want to do it, if you want to monitor any traffic and you need a copy of the traffic on the computer. So in that sort of scenario, you may want to have your computer attached to a hub. But a more ideal solution is using a switch, where the switch will send a copy of the packet to a packet sniffer tool, where wherever you install that tool, it will just send it to that particular computer. Okay, so there are two. So this is how you can do the port mirroring. The another one, we got something called Cisco SPAN, which is called Switch Port Analyzer. This is again another feature on a Cisco switch that sends a copy of frame entering a port out another port on the same switch. Okay, the same thing that we had a look before. And then a computer that is running a packet analyzer or IDS might be at that end of the port. Okay, so what on this figure you can see we got the ingress traffic. Okay, the traffic that entered the switch, and then we go egress traffic. That's the traffic that leaves the switch, and then we go something called a source span port, a port that is monitored with the use of span feature. Okay, and then we got the destination. That's the port that monitored the source port, usually where a packet analyzer or IDS is connected. So you can see the IDS is connected here. Okay, so the next one is now the configuration. Okay, how we can configure Cisco SPAN using intrusion detection. Okay, over here you can see we got some command. The command is monitoring session, and then you have to specify the number, for example 1, and then you have to specify the source, and here you have to specify the interface, maybe S001 or FE01, depending on whatever you're monitoring. And again, and then we go associate a span session with the destination port. So again, the command is same. Instead of source port, you have to put the destination port. And to check whether this has been done correctly, simply use show monitor command. Okay, it will show you the configuration. And that's it. That's our end of first session. Any question, guys? All right. Thank. So now we're going to look at the section 5.2 IPS signatures. Okay, so after this session, you should be able to understand what is IPS signatures are, what are their features, explain the IPS signature alarms, manage and monitor IPS, understand the global correlation of Cisco IPS devices. Okay, so first of all, IPS signature characteristics. So the signature is a set of rules that IDS and an IPS use to detect typical intrusion activities. I think in one of the presentation we discussed how Cisco monitor all the attacks which are happen globally. They have a team of scientists, researcher who basically always looking or investigating any attacks which are happening all over the world, and they have a database of such attacks as well. Okay, so all the system that Cisco especially the security system that Cisco offer, they are linked to those databases. Okay, and after a certain time those system get sync with those online databases and get the information or update about the latest security attacks or threats or any malicious softwares or any web links, you name it, anything which through which the attacks can happen. That information is stored on that databases. Okay, and there's a signature. When it's come to the signatures are simply the information which get downloaded about a particular the the attacks which are happening over the world. And there are a set of rules and that IDS and IPS system uses to detect these intrusion activities. So in signature, there are three attributes. One is called type, and then we go triggers, and then we go actions. Okay, now we're gonna look at these into one by one. Now, when it comes to type, signature type, there are two types. One is called atomic, another one is called a composite. Atomic is the one where the signature consists of a single packet or activity, and that is examined to determine if it matches with the configured signature or not. So this is, you can call a single packet a matching mechanism. Whereas the composite, you are looking at a sequence of packets, and you have some sort of rules which look at that sequence and try to find out whether this is a legitimate communication or is some sort of a malicious attack. Okay, so if it's a single packet, it's atomic. If it's a series or multiple a packet or sequence of operation, then it's called a composite. So there are two types. Then the next one is signature files. Okay, as a new threats identify, new signature file must be created and uploaded to the IPS system. Okay, a signature file, they usually contain a package of network signatures, and these signature files can be downloaded from Cisco website. Obviously, you have to have a account with the Cisco as a customer account, and then it will let you download all the signature files that you can use and upload on for your IPS system. Okay. And moving on to signature micro engines. So there are 5 micro engines. First one is called atomic. That's a signature that examines simple packets, which we mentioned before. Then we got services, and these are the signature that examines the many services that are attacked. Then we got something called string that use regular expressions, a pattern to detect intrusion. Then we got multi-string that support multiple pattern matching and trend lab signatures. Then finally, we got something called other. That's the internal engine that handle miscellaneous signatures. Why you think they are no use? Yes, yeah. Yes, unfortunately, yes. Yes, that's how, because this is a Cisco's qualification as well. So they want to promote their own stuff. No, this no, especially this CCNA security. This was not a part of CCNA. This was the actual extra stuff that, or let's say extra module which was added in, and or we are not covering, let's say, the security in that much details in a CCNA exam. But the new ones, that the new exam which they which they have published, and there are information about lots of information about the security as well introduced, and also the wireless communication, which was not a part of the original. Yeah, yeah, exactly. So you have the wireless communication now introduced as a part of Cisco, and also I'm teaching those one to this year one students. Routing, yeah, they are routing, switching, and wireless technologies. Because you have, but yeah, Yeah. No, the one thing I can offer really, because initially I was covering routing and switching. Now I have moved to wireless, as you know, the LAN. So if you guys want, if you want to attend those sessions, feel free to attend it because they're usually 1 hour long session. One is on Monday from half 4 to half 5, and another one is on Tuesday morning, which is from 9. I usually finish about in 1 hour or 1.5 hours. So if you wanna, join in to listen in to the session, feel free. I've got 4 chapter to go, so that means the two more weeks, and I will finish that one with them. So if you do want to come in and join and learn about that one, I can send you the invitation as well. Yes, I think I can send you the link to that one. I've just started this week, wireless LAN. So the morning today was the first session. So I can find out that recording. I've already got the recording. I'll forward it to them. So I will send it to you a link to that recording as well. Okay, yeah, that's fine, no problem. And again, if you wish, I will send you an invite anyway. If you feel like if you are free, if you want to join into the live session, come in and you can ask questions as well. If not, then you can watch the videos. Okay. No, that's fine. So let's go to the signatures, more of signature files. So again, as I mentioned, they are available to download from the Cisco websites as well. You can download from there. Again, you have to be, I think, a paid customer for that one, or you have to have IPS system with them. Then you can download these softwares. So now we talk about the signature. The next thing was alarms. Okay, signature alarms. So we have different types. Over here we got pattern-based detection, and we got anomaly-based detection, and then we got the policy-based detection as well. Then finally the honeypot-based detection. Um, there are some disadvantages of all the detection types. For example, the one of the advantages of pattern based detection is they're easy to configure, fewer false positive, good signature design, and problems are no detection of unknown signatures. And initially you can get a lot of false positives as well. False positive means like whenever they detect there's something going on, and that these are their disadvantages. And you can read more about this one on our NetAcad, on NetAcad website. There lots of information is given on that one as well. So looking at each of these in more details, pattern-based detection. Pattern-based detection is also known as a signature-based detection, and it's the simplest triggering mechanism than any other method which are available. It search for a specific and predefined pattern that must be there in the signature file. A signature-based IDS and IPS sensor compare the network traffic to the database of known attack, the database which I mentioned it to you, and trigger an alarm or prevent communication if the match is found. Okay, so in a simplest term, you have some sort of, in a pattern-based reduction, you have a patterns, which is you get it from the database, okay, which is managed by Cisco, and if anything matches to that pattern, then it raises the alarm or it basically stop the communication. Okay. So that's your pattern based. Again, there are two types that we discussed before: atomic, which is by packet, or you can go. You have a composite signature as well that examine a multiple item or a series of activities or processes. Okay, so there are two. Then the next one was anomaly-based detection. Okay, and this is also known as a profile-based detection. It involves the first defining a profile of what is considered normal for a network or host, and this normal profile can be learned by monitoring activities on the network or a specific application on the host over a period of time. Okay, it can also be based on a defined specification, such as RFC. After defining normal activity, signature, trigger, and action, and excessive activity occur beyond a specified threshold that is not included in a normal profile, and this is where the triggers or alarms happens. Again, they are divided into two. You have atomic signature, and also you got the composite signature as well. Atomic signature is where no state required to identify activity that deviates from normal profile. While in a composite one, the state required to identify the activity that deviate from the normal profile. Okay, the example could be for the composite one, verifying protocol compliance for HTTP traffic, and for the atomic one, it could be directing traffic that's going to destination port that is not in the normal profile. Okay, so this is what your anomaly based detection is. Then after that, you have a policy base or honeypot based detection. The policy based detection is something called a behavior based detection. It is similar to pattern based that we discussed. The only difference is instead of trying to define a specific pattern, the administrator or the network engineer define a behavior that are suspicious based on historical analysis. Okay. Then you have again two types, atomic and composite. In atomic, no state required to identify undesirable behavior, while in other case, previous activities are required to identify these behaviors. Now, in terms of benefits of iOS IPS solution, as I mentioned, there are a number of them. The Cisco has implemented IPS functions into its Cisco iOS software as well. So they come in as a software, or they also come as a hardware, but they are part of your iOS software. Now the Cisco iOS IPS uses technology from Cisco IDS and IPS sensor product line. So the benefits of having iOS-based IPS solution, it uses underlying routing infrastructure to provide an additional layer of security. So we look at the routing and then provide you the security. It is inline again, before the packet goes onto the networks, it basically have a look and find out if there is any issues with that packet. And next one is it provides threat protection at all entry point to the network, because the router is the one who basically through which the networks can come in and go out from the network, isn't it? So and also this provide this provides you the protection against all the entry point to the network. And also especially when the when you talk about the combination like IDS and Cisco iOS firewall, VPN or NAC solution. And the last one, the size of the signature database used by the devices can be adapted to the amount of available memory in the router. This is a huge benefit, because the size can be massive of these databases. And if you go a router with the less memory, and this is where you can have an issue. But well, fortunately, you can adjust your size. Okay, how much you need, you can adjust that amount based on the available memory in the router. So these are some of the benefits. Now lastly, we go alarm trigger mechanism. We have several types. We got something called a false positive alarm. This is for a false positive alarm is an expected, but we go. Guys, you are there, or I just hear a noise? I will. Hello. We are discussing the Chapter 5 IPS system, which is the intrusion prevention system. Okay, and I'm just halfway through the presentation. I'm recording it as well, and I will send you a link so that you can watch the initial part of this presentation. Okay, so let's carry on. So we got that. I was talking about the triggering mechanism. So we have a number of them. For example, a false positive alarm, a false negative alarm, a true positive alarm, and true negative alarm. When you talk about the true negative alarm, it describes a situation in which a normal traffic does not generate alarm. Okay, that's a true negative alarm. A true positive alarm is a situation in which an intrusion system generates an alarm in response to a known attack traffic. Okay, so that's a true positive. Then further you have the true false negative alarm as well, in which your IPS system fails to generate alarm after processing attack traffic that intrusion system is configured to detect. So this is when this a false negative alarm is generated. Now you go false positive alarm. This is an expected but undesired result. A false positive alarm occur when an intrusion system generate an alarm after processing a normal user traffic that should not have a triggered an alarm. Okay, so this is when you have a false positive alarm. So you have four different types of alarming mechanism. Okay, so the next one we got the IPS Signature Actions. Um, no, that's fine. We can stop here then, and we can just. Okay, let's start with our next session, which is 5.2.3 IPS Signature Actions. So, let me maximize the screen. Okay. Now, signature actions. When a signature detects the activity for which it is configured, then the signature trigger one or more actions. Okay, and there are several categories of actions that can be invoked, which are mentioned in this figure over here in this table. For example, generating an alert in which the alert is produced, or logging the activity, or dropping or preventing the activity, or resetting a TCP connection, blocking future activities, or allowing activities. Okay, we're gonna look at all of these action one by one, starting with generating an alert. Okay, so monitoring the alert generated by a network-based or host-based IPS system is very important to understand the attack being launched against the network. Okay, as you can see in the table, an IPS can be enabled to produce an alert or a verbose alert. In the first category, the action this action write the event to the event stored as alert, but in a produce verbose alert, the action include an encoded dump of offending packet in alert as well. Okay, and it does write in an event store all this information. So there are two types of generating alert. Moving on, then we have a logging activities. Okay, in some situation, administrator does not necessarily have enough information to stop an activity. Therefore, the logging the action or a packet that are seen so that they can be analyzed later in more detail is very important. As you can see in the table, an IPS can be enabled to log attacker packets, a peer packet, or just victim packets. Okay, in a log attacker packets, this action start IP logging on a packet that contain the attacker address and the sender, and sends an alert. So log attacker is basically the information about the attacker. Log victim packet is the information about the victim, and log peer packets is the information about both. Okay, when you say information, is basically their IP details and other info and IP addresses of both devices, and all this information get written into the event store. Okay, the next one is dropping or preventing activity. One of the most powerful action that an IPS device can perform is to drop packet or prevent an activity from occurring. Okay, as you can see in this table on the screen, an IPS can be enabled to deny the attacker packet and deny connection or deny the specific packet. So there are three things that IPS can do. In deny packet in line, this action terminates the current packet and future packet from the attacker, and it also does the entries may be removed. And the next thing it does, the sensor maintain a list of attacker currently being denied by the system. So it's also maintain the list of the attacker, and these entries can be removed from the list manually or automatically based on the timers. Timers, they are basically sliding timers for each entry. Therefore, if the attacker, for example, attacker A is currently being denied but issues another attack, then the timer of their attack is reset, and attacker A remain on the denied attacker list until the timer expires. The last one is if the deny attacker list is at capacity and cannot add new entry, the packet is still denied. Okay. Now the next alert is a deny connection in line. So this action terminates the current packet and future packet on the TCP flow. And deny packet in line, this action terminates the packets. Looking at the next one is we got something called reset the connection and blocking the activity. So in this one we have reset a TCP connection, request block connection, request block host, request SNMP trap. So the TCP connection, reset TCP connection simply means this action send a TCP reset to hijack and terminate the TCP flow. And in request block connection, this action send a request to block the device to block this connection. And block host means block the host. And SNMP trap means send a request to notification application component of the sensor to perform a simple network management protocol, SNMP notification. Okay, and the alert is then get written into event store, even if the producer alert action is not selected. Now we're going to go to the next session, which is manage and monitor IPS. Here we're going to look at how we can manage and monitor IPS intrusion prevention system. Okay, here we go. The factor that we need to consider when implementing a monitoring strategy. There are four things we have to consider: management method, event correlation, security staff, incident response plan. Okay. Starting with the management method, the IPS sensor can be managed individually or centrally. Okay. Configuring each IPS device individually is the easiest process if there are only a couple of sensors. If you got multiple sensors, this is where you should manage it centrally. Then event correlation means that it refers to the process of correlating attack and other events that are happening simultaneously at different points across a network. Having the device drive their time from a network time protocol, NTP, NTP server, enable all the alert generated by the IPS to accurately timestamp. So event correlation is very important, and this is where the NTP can help, which is the network time protocol. You can configure, you can drive all the time from this server, so there is no mistake on timestamping. Okay. The next thing you have to consider is the security staff. Okay, the IPS device tend to generate loss of alerts and other events during the network traffic processing. Therefore, the large organization, they need a security staff who can analyze these activity and also determine how well the IPS is protecting the network. So they need a security staff for that one. Lastly, incident response plan. If the system get compromised on a network, a response plan is needed. This is a detailed, it could be a document as well, or a process in place that basically tells you what to do in this sort of scenario. Now another one called secure device event exchange. When attack signature is detected, the Cisco IOS IPS feature can send a syslog message or an alarm in a secure device event exchange, which is called STEE. Okay, you can see on the STD protocol and the syslog in this picture. The STD protocol was developed to improve the communication of events generated by the security devices. Okay, so this is what happens when the alarm is generated and the information get onto STD protocol and also a syslog. Here we got some best practices of IPS configuration. So the first one is update signature pack automatically when setting up a large deployment of sensor rather than manually upgrading each sensor. Obviously, it makes sense because it's very time consuming, and also you do not want any loopholes, because if there is a delay in updating, during that delay somebody can attack on your network as well. So it's always good to automatically update these sensors. Next one, download new signature pack to a secure server within the management network and use IPS to protect the server from the attack by outside party. And then third one is place signature pack on a dedicated secure FTP server within the management network. So it has to be secure. Configure the secure FTP server to allow read-only access to the file within the directory on which the signature packs are placed. So it should be read-only access only. Lastly, configure the sensors to regularly check the secure FTP server for new signature packs. So these are the few things you should consider when configuring IPS. Now we can next session 5.2.5 IPS Global Correlation. So in addition to maintaining signature packs, Cisco IPS include a security feature called Cisco Global Correlation. Okay. With global correlation, Cisco IPS devices receive regular threat updates from a centralized Cisco threat database, which I mentioned before as well. And it's also called as a Cisco sensor-based network. Okay. The Cisco sensor-based network contains real-time information about known threat on the network. And the goal of these Cisco global correlations are dealing intelligently with the alert to improve effectiveness, improve protection against known malicious site, and sharing telemetry data with sensor-based network to improve visibility, simplify configuration setting, and also automatically handling of security information uploads and downloads. So the figure shows you one architecture and also how the IPS sensors can be configured to participate in a global correlation updates. So as a client, you can download, the security updates from the Cisco databases, and you can also contribute towards those to those databases as well. For example, you come across any threat, and then you can turn on some setting on your IPS system, and that will automatically update those databases. Okay. Now, in order for global correlation to occur, the raw information in a first collected by the Cisco sensor-based network, and it basically gather following information. For example, signature ID, attacker IP address, attacker port, maximum segment size, and all sort of like a port, victim IP address, and port number, signature version, and all sort of information are collected before it get uploaded onto the global correlation or a Cisco sensor-based network. Okay, so when you participate in a Cisco global correlation, IPS sensor can periodically receive regular threat update from the centralized Cisco threat database, which is called Cisco sensor-based network. This includes information about botnets, malwares, spammers, and any other threats. Okay, the IPS sensor can use these reputation filters to deny IP addresses that are blacklisted before the sensor does further analysis on the traffic. And these reputation filters offer the first level of defense by defining traffic based on IP address in the blacklist. And the Cisco sender base website, which is also called sender base. I think it has been updated now. It has been changed, and you can have a look at that one as well. And this figure you can see illustrate how the Cisco AS a bootnet traffic filters. So there's a traffic. Oh, could you use my laser? You can see the malicious traffic is going to your Cisco firewalls, and the firewalls use SIO system and basically send alert to the security team. So that they can prevent, mitigate, and remediate against these malicious activities. Okay, now finally we got the section 5.3. This is the last section about implementation of IPS. Here we're gonna understand how to configure Cisco iOS IPS with the CLI and explain how to verify and monitor IPS. Cisco iOS IPS means the IPS which is available on on operating system as a software as a service. Okay, so there are 5 steps, okay, that we have to perform. The first one is to download the iOS IPS file, then create iOS IPS configuration directory in Flash, and configure iOS IPS crypto key, enable the iOS IPS, and load the iOS IPS signature package to the router. So now we're going to look at each of these points one by one. So the first one is download iOS IPS. So before you configure IPS, it is important to download the iOS IPS signature package file. You can download it from the Cisco website. The specific IPS file to download vary depending on the current release, and only registered customer can download this package and the keys. Okay, so you have to register with them. Now, the second step is to create an iOS IPS configuration directory. So you can see over here, we got some commands that you can use. mkdir is the one that you can use to create a directory. And once the directory is created, you can use a command called dir and the Flash. So it will show you all the directory which are created on a Flash. Over here, you can see IPS dir is listed here. Okay. So once you done this one, the next job is to configure an iOS IPS crypto key. Okay, the third. So in this third step, you will configure the crypto key used by iOS IPS. The key is usually located in the realm Cisco pub key.txt. This is the file name, and the key you can see over here as well. So this is the key, and this is the name of the file where this key is usually placed. So once you got the key, you have to enable now the iOS IPS. To enable this one, we got the command called IPS and the rule name, and you have to specify the name of the rule, and then configure the IPS signature storage location, again where you want to store it, and this is what you have to do. Then specify the method of the event notification, whether you want to use a log or SDEE. The SDEE basically send messages in a SDE format, while log send a message in a syslog format. And then finally, we're gonna enable iOS IPS. So we have looked at this one before. So you have to run the command called IPS name. You have 2 parameters in and out. You can in means apply IPS to inbound traffic, out means to an outbound traffic, and then load the IPS signature package file in RAM. So this is the last step as administrator to upload the signature package to the router. The most common methods are FTP or TFTP that you can use. To copy the downloaded signature file from TFT server to the router, you can use a copy TFT command. Okay, this is the command you can see over here, copy TFT command. You have to use with the ID config parameter at the end of the command as well. This is a parameter over here. Okay, an example is shown, and this is one of the example of how you can do this one. So this one is how you can, we have done this one. This is one of the example how you can basically load the IPS signature package in a RAM memory. And the next thing is retire and unretire signatures. The Cisco iOS CLI can be used to retire or unretire individual signature or a group of signature that belong to a signature category. So when a group of signature is retired or unretired, all signature in that category are retired or unretired on the same time as well. For example, in this figure, in this picture over here, it shows you a sample of retiring a specific signature. In this example, the signature 6130, which is over here, with the sub ID of 10 is retired. Okay. And then in the picture over here is you can see any unretiring signature category, and in this example all the signature that belongs to IOS IPS basic categories are basically unretired. Okay, then we're gonna look at how we can modify now the signature files. So if you wish, you can use iOS CLI to change the signature action for one signature or a group of signature based on signature category. So to change the action, you have to use a command called event action command. So this is the event action command that you have to use. It has a number of parameters. For example, deny actor inline, deny connection inline, deny packet inline, produce alert, reset TCP connection. So you can use one of these parameters as well. Finally, to verify the iOS IPS, there are a number of show commands available that can help you to verify to verify whether the IPS has been configured properly or not. To specify the method of event notification, you can use IPS notify command. Okay, uh, uh, you can use this globally configuration mode. The log keyword sends the message in a syslog format. Okay, and STE keyword send the message in a STE format. So you can either use a log or STE. You can use one of these methods to report IPS alerts. So if you want to enable STE, the previous one was a log, we mentioned it here. So if you want to do STE, so you have to use the keyboard STE, and STE is also a preferred method of reporting IPS activity as well, because STE use HTTP and XML, okay, to produce a standardized approach. So you can use IPS notify STE command to enable STE on your router. Okay, and that's it. That's the end of today's section. We described the IPS technologies today and how they are implemented. We explained the IPS signature and describe how IPS implementation process works. So any question, guys?